Good afternoon. Very happy to be there. This afternoon, I will talk about Patroni and Pgbackrest. This morning has been quite interesting talk from Stefan Ferkot about Pgbackrest Advanced, but in this case, it made my life simple because I could just keep some topics already covered by the previous talk. So, but in any way, there's a lot of stuff to go through, so let's start. I will tell you just a little about me. This guy is me. I'm on the back, showing you the back. The cat on my shoulder is my no longer kitten named Ozzy. I was born in 1972. I look younger. I started with the IT in 1982, joined the Oracle Secret Society, the Oracle DBA Secret Society in 2004. I love PostgreSQL since the 2006. At that point, I have a Postgres tattoo on my right shoulder. This guy, the FreeBSD, joined the tattoo a couple of years ago. And I work as a freelance DevOps data engineer, but I consider myself a DBA after all. Those are my contacts. My blog is not really active, honestly. My Twitter, GitHub with some projects, my LinkedIn, and my YouTube channel. I added also this thing, but just publishing my videos in learning to play the guitar is something I really want to do for a very, very long time. So let's move into the agenda, the table of contents for today. I used some reference to the movie Tron, so I can show you how old really I am. And we will have greeting programs. We will learn about the programs in our presentation, the greet, how to set up something, the lifecycle mates, complete with Pgbackrest, the installation, end of line, what happens when disaster strikes, and I fight for the user. Just final remarks and wisdom about what we discussed in this talk. Let's start from greeting programs. So our friend Tron, Clue, and girl, I don't remember the girl name, but she's amazing anyway. So, PostgreSQL, our beloved database, is an enterprise class RDBMS. We know. Is it compliant with HA, disaster recovery? We have a lot of stuff with just one tiny little catch. There's no built-in mechanism for automating backups or failover. We have to do everything by hand, so set up stuff, usually. And that was the way we used it to work. I also made a lot of stuff, but nowadays things are no longer this way. We have great tools for doing that. So let's forget about bring your own tools, shell script, manually operated Cthulhu summoning for setting up auto failover options in Postgres. Is much better to rely on something else like Red Manager, PG auto failover, PostgreSQL automatic failover for friends PAF, or the topic of today, Patroni. Patroni has been built by Zalando. It's a great tool. It's written in Python, relies on DCS to maintain the cluster status, and this requires a lot of change of perspective. And is available in the PGDG official repository, so apt and yum or DNF, whatever. We can get just installed in a very simple way on the main kind of distribution, so Debian-based or RPM-based, Deb-based or RPM-based. Patroni, as already said, is developed in Python, supports for different flavors of DCS, etcd, console, zookeeper. We will see the example with etcd. Support for Python Raft requires the PySyncobj module for working properly. Automated bootstrap and replica setup. So there's nothing to do when you need to build up a new instance. We will see. Automated failover or switchover. Centralized configuration for Postgres stored inside the DCS. This is the way Patroni maintain the consistency across the nodes. Very resilient to the split brain. The system relies on tokens, so it's very difficult for, well, almost impossible for the system to have a split brain, because an older primary, if he fails to acquire the token, it just becomes the follower to the new primary. It's completely automated. And using HA proxy or PG bouncer, the connection can be routed via API check. So those two tools can query the API, understand and know exactly what's the primary node to connect to. So it's also possible to automate the connection routing. But we are not covering this part today. Caveats. As I said, everything is managed by Patroni, so we need a change of mind. No more manual edit for the configuration files, for example. Even the restart, we will see later, it should be managed by Patroni itself. Some part of the documentation is unclear. Yes, standby cluster, I'm talking of you. The documentation is pretty good. I think there are some parts can be improved. In particular parts not particularly common as use cases. The standby cluster is one of those. Configuring a cluster, Patroni cluster without a primary, using a remote streaming replica, a remote standby or a remote primary for just sending the WAL data into this particular cluster is not explained very clear, to be honest. It took me a while for getting grip on it, but maybe I can just contribute to improve that. Client in only interactive mode. Patroni CTL is an amazing tool for managing Patroni. Unfortunately, is interactive. There's no batch operation. And so any automation for operating via API call, it has to be built using any sort of tool. The example on the documentation shows curl, but this can also be done through the Ansible URI module for just calling the API. Let's move to the other actor, the other side of the coin, the backup, so DR. Back in the days, we used it to do logical with pgdump. It's not a good idea to do anymore. Yeah, pgdump is still useful for validating the data, in particular forcing the read of any single block so we can detect if, in particular if it coupled with the PG checksums, is very useful for understanding if our blocks are corrupted or not. But when you do a dump with pgdump, you just get a snapshot. If you do every day, you can lose 1 day of worth of data if you are unlucky enough to get the crash and lose the database before a new pgdump is complete. So physical tools. The physical tools implement the point-in-time recovery, basically. So we can restore at the last second. Is much more efficient in terms of, and much more dependent on the from the perspective of high available data. So we are PG-based backup. So PG-based backup is part of the Postgres distribution. We have Barman, a tool developed in Python for automating the backup and recovery. WAL-E, WAL-G. The WAL-G is the latest incarnation, has been developed in Go, if I correctly remember. And our friend Pgbackrest. Pgbackrest is simple, reliable solution for automating backups. I'm not spending too much on this part because we already seen Stefan talk this morning, but it's a community-driven project. It's a physical backup tool, implements HA and DR, supports different flavors of backup from full to differential incremental. It supports parallel job for performing the backup and the restore for speeding up our operations, can backup from standby server, asynchronous while push and pull. It was initially developed in Perl, now is fully migrated to the C code for performance. Actually, is a self-contained C executable, and that's amazing. It's completely monolith. You can use it without any risk of breaking dependencies. Is an ini style configuration. The configuration is in ini style. I really like it. It's also like Patroni is available in Debian PGDG repositories. And initially, it supported only S3 as a cloud backup option. Now they add the GCP and Azure in the supported cloud backup. We will see the GCP configuration today. Supports multiple repository for the backups we've seen in this morning. Another point of strength, I really love this part, is the self-contained backup repository. We just need the repository for being able to restore our database. There's nothing else for required, differently from other tools that use the a Postgres database for storing the backup catalog. Caveats. Configuring remote backups via SSH may be complex, require a different configuration for the backup server for the database. There's a different philosophy for the backup and the restore, so it requires attention. When configuring archive push qmax, beware, because if you overfill this value, there's the risk of all files not being archived. So there's the risk of having an invalid progression of WAL files and not completely supported point-in-time recovery. The backup, it will stop at the last contiguous WAL file available. And if in doubt, rule of thumb, always RTFM when doing operation on data. Whatever is HA, DR, or managing data, always RTFM. And for an advanced topic we are seeing this morning, so I think this entire session will be available offline after we finished. So if you missed the talk, has been the first one, so please rewind the video and watch it. It was absolutely amazing talk. So let's move into the grid. How do we configure Patroni? Let's start from the idea. This is a super biased configuration describing Patroni. etcd is just one node. It should be at least 3 for having a way to elect a leader within the etcd cluster. Patroni, it doesn't have any connection router, but in this case, it's just fine. We need to just show how to bootstrap a Patroni cluster. So we have the 2 Patroni nodes talking with TCD. etcd decides, well, assigns the leader to be, and the leader will push the data, will stream the data through the streaming replica to the follower. So Patroni 1 is the leader, and Patroni 2 is the follower, and the streaming replica is working, is replicating the data from across the 2 nodes. In our example, we will use a CentOS 7 and the GCP bucket. I didn't use it initially. I talked about using Rocky Linux as a new the new CentOS incarnation, not really a CentOS incarnation. But this talk last week, it wasn't there, so it took me. I had to work very, very fast for writing this talk, so I used something that I knew. So we have 3 machines: etcd1, Patroni 1, Patroni 2. The operation, the steps to do is optionally set up etc hosts with the names. If we are using an environment with the DNS, this is just optional. It's very useful to have to being able to call the machine by name. Open the required ports on Firewall D, on etcd and Patroni. Install etcd on the etcd server. Configure and start the etcd. Install Postgres 13 and Patroni on the 2 Patroni nodes. Configure Patroni, start Patroni, and profit. Very simple. So this is just the optional step for setting up the hosts, just a match between the IP address and Patroni. In my experiments, for writing this talk, I used a VirtualBox machine configured inside into a local network for having the machines talking to each other. But there are obviously different options for doing that. So next step is configure Firewall D. Firewall D is the firewall daemon for provided by CentOS, and the command is very, very simple. So we need to specify sudo firewall D cmd, specifying that the port has to be permanent. The zone is the only one installed initially, so it's the public zone, and add the port to on etcd, the two ports used for advertising and connection, 2380, 2379 on TCP protocol, and then reload the Firewall D through systemctl. On Patroni, we need to open two ports, the Postgres port, the Postgres default port 5432, and the Patroni API port, which the default is 8008. Again, after configuring the Firewall D, sudo systemctl reload Firewall D. At this point, on etcd, on the etcd machine, we just need to do sudo yum install etcd. Wait for the installation, and then into the directory etc etcd, we need to edit the, the prefix is quite confusing because it's called etcd.conf, but in fact is an environment file. All these variables are just environment variables for Bash, for the shell. So we need to set all these variables required to open the etcd listening to a different interface. Instead of the localhost, we need to open the DCS for listening on a specific IP address. By default, etcd listens only on localhost. So when we have set up this thing, we also specify that the initial cluster state is new because there's no cluster state yet, no cluster etcd in our machine yet. So, and then we just need to systemctl sudo systemctl start etcd. After the start, we can use etcd-ctl specifying the endpoint, checking the cluster health, and we should get this nice message that the cluster is healthy. And we are done with the etcd. Let's move on the Patroni machines. On the Patroni machines, we need to first install the pgdg Red Hat repository, which is just downloading a no-arc RPM, which will install and configure the repository on the YAM archive, and then use yum install PostgreSQL 13, PostgreSQL 13 contrib, and PostgreSQL 13 server. It will install basically everything we need except the source code for making this machine work. And this is for the PostgreSQL install. We are not creating the service or the instance at this point. We will let everything do by Patroni. We will get everything done by Patroni. At this point, we can move to the Patroni install. Before installing Patroni, we need to install the EPEL release. It has more libraries available in the CentOS ecosystem. And then we can install Patroni, and the Patroni TCD module, the extension is some sort of extra data, is the set of libraries used by Patroni for connecting to etcd. In case we use a different DCS like Zookeeper or Consul, we need to install Patroni-Consul or Patroni-Zookeeper. But in this case, it's just etcd. After doing that, we create a directory in etc named Patroni, and inside this directory we create a configuration file patroni.yaml. Another thing I really like about Patroni is the fact that the configuration file is YAML and is very structured for the scope, and is translated directly into the logic of the Python dictionaries. This is not related with the niceness of YAML, but is with the niceness of the translation into the Python objects. So our configuration in Patroni, we need to specify several things. First of all, the scope, which is also the cluster name, in this case is test, the namespace, which is the folder inside the DCS where all the configuration will be created. So when we bootstrap this Patroni, we will get inside our etcd a directory Patroni_test. Inside this directory, we will get another directory named test, our cluster, and inside the cluster, inside this directory, we will get all the configuration data for the nodes we are adding to the Patroni cluster. So another thing important is the name for our node. It has to be unique within namespace and scope. So in this case, it's Patroni01. On the Patroni02, we will get the Patroni02 instead of for the name. Log directory, the REST API listen and connect address. Look at the port is the one we opened before on the firewall, and finally, and then we need to specify the etcd hosts to connect to. So the IP address, we could use also the names with the port we opened before with Firewall D. And then it comes the bootstrap section. The bootstrap section is read and executed only when Patroni is bootstrap for the first time. So it means it finds an empty or not existent data area, and also it finds the etcd or the DCS empty. So it has to bootstrap completely from scratch. When this happens, when the bootstrap starts, all the information written under this specific key are used for configuring our cluster. So the DCS party, it sets the some settings for like the loop weight, retry timeout, and the maximum lag on failover. But what's important is the Postgres section and all the others. Under the Postgres section, we specify particular operating parameters in terms of Patroni, but also we can specify the Postgres parameters. So, for example, we have the use PG rewind set to true. It's not really clear on this slide, but it's set to true. It means when remastering, when recreating, reattaching an old primary to a new primary, use PG rewind for speeding up the remastering. Use replication slot is set to false, but you can set to true if you know how to do. Again, RTFM. And parameters, it sets the parameters for the newly created Postgres instance. In this case, I'm just setting one level to replica. It's redundant because it's already the default. Archive mode is set to off, and Unix socket directory is set to specific value, var run PostgreSQL. This is useful for having local connections automatically through the sockets, because PSQL will go searching to this directory. Then we have the method for initializing our instance, which in this case is initdb. The default is initdb. So it will call initdb with the options specified under the dictionary, under the key initdb. In this case, we are adding to the normal initdb operation encoding set to UTF-8, and also we are enabling the data checksums, which is always a good idea to have. So also, after initdb, we have the PGHBA section where we can specify additional lines to add to the PGHBA after running initdb. And finally, the users, which at the moment in this example is empty, it also allows us to specify the users to create after initdb is executed. So with the bootstrap section, we define completely our database, our cluster, our instance. We don't need to do this thing manually anymore. The Patroni, it will do everything for us. Let's move into the operational part of the configuration, because bootstrap is executed only when bootstrapping, but we also need to tell Patroni how to operate normally. And this is done through the via the key PostgreSQL, which specifies several things. For example, the listen is a combination of listen addresses and port. In this case, it's star and 5432. Connect address, where Patroni should connect for checking his own internal stuff. Patroni 015432. Data directory, where we need to create the data directory. Where is located the binary directory for PostgreSQL? There's also the configuration directory. It's very specific for Debian, because Debian it doesn't install the configuration files inside the data area. So there's all this sort of stuff. PGPass authentication, specifying the replication super user and rewind. Unfortunately, the password is set in clear, so this file should be extra secure. Parameters for operating, so one level replica, archive mode set to off. Again, we have the socket Unix directories and the tags, which are operating tags to set over the specific node. After configuring this patroni.yaml, we also need to set up the systemd service file. So in etc systemd system, we will create the patroni service file. Inside this file is very, very simple. We have the description of the unit, after which target it should be started, the user and the group that should run Patroni, an eventual environment file, the working directory, and so on. Exec start, so we are running bin/bin /patroni with the configuration file we have defined previously. Very important, exec reload. So how to reload Patroni? By sending the SIGAP to the main bit. And also, it's very important to set the kill mode to process, because the sig kill, it should be, well, sig kill, the sig term, the shutdown signal, it should be sent only to the main process, so Patroni can shut down the nodes gracefully. The timeout for the server to wait for start and stop. Restart equal no, because if the database, if the system crashes, we want to inspect what's happening before having an automated restart. So automated restart usually in the database universe is not a nice thing. And wanted by multi-user target. This is internal systemd specific configuration. So after setting up the unit, we need to reload the daemon. So sudo systemctl daemon reload, enable the service, and start the service. As soon as we start the service, Patroni on the first machine, I'm assuming it's Patroni 01, it will contact the etcd. It will see that the etcd is empty, and then it will initiate the bootstrap operation. etcd, it will return the token leader. So it will say, Patroni 01, you are the leader, and you will become the primary. So bootstrap through initdb, with the configuration we are set in the bootstrap section, it will create the cluster and start the instance automatically. And at the end of the story, so when the cluster is up there, the Postgres instance is up and running, with the command patronictl-c with configuration file list, we will see the only node inside our Patroni. If you see, we have the cluster named test, our scope, and also the number within the parentheses is the database unique identifier, the cluster unique identifier. Is something you will get from the pg control file output. So we are ready for starting the second node. As soon as the second node comes up, it will try to acquire the token lead, the token leader on etcd, and the etcd will say, oh, there's already a leader, and then Patroni 02 will become a replica. It will start PG-based backup against Patroni 1, and we will create a complete physical replica, and also all the part related with the primary connection, primary constring, the connection data. It will be managed and generated automatically by Patroni that will establish the streaming replica from the Patroni 01, from the leader. And at the end of the story, Patroni CTL, it will show the two members, one leader, one replica, with the timeline 1 because we are just initdb. We are just initialized with initdb this instance, and the lag in megabytes. If we add writes on the leader, we will very likely see the lag in megabyte increase because it will be calculated in terms of lag between the primary and the secondary in terms of replay operations. And that's it. We have a very nice HA solution. But this is not sufficient, because if we lose the entire set of machines, we are screwed. We cannot recover anymore. And here comes Pgbackrest. Pgbackrest is based on WAL archiving rather streaming replication. And it can also back up the contents of the data area. I'm not showing in this case how to do it, but you can back up from the standbys. So it's even better for backing up very, very quickly the data without overloading the primary. So in this diagram, we are adding a GCP bucket, Pgbackrest installed on Patroni 1 and Patroni 2. Patroni 1, which is the leader, is archiving into the GCP bucket the WAL files. Patroni 2 is using the streaming replica, but if for some reason the streaming replica breaks down and the WAL file is no longer available on Patroni 1, it will fall back on Pgbackrest for replaying the missing WAL file. So it will also ensure an extra robustness on our streaming replication, because we will have a fallback procedure for the WAL restore. So let's configure and install the software. Again, install Pgbackrest on both Patroni servers, create the GCP bucket, create the shared key JSON file, and grant access to the GCP bucket to the user owning the shared key. Configure Pgbackrest for using the GCP bucket, configure Patroni for using Pgbackrest, run Pgbackrest first backup, so create the stanza and then run the backup and profit. I'm skipping the part related with GCP. The GCP part is not exactly pleasant to go through. You need to just navigate the Google interface for generating all this sort of stuff. So it's something I do not consider useful for this talk, and also it will take us a lot of time for going through. So I'm just skipping. I'm assuming I have the GCP bucket and the JSON file in place. So after installing Pgbackrest, which is basically a yummy installed Pgbackrest, we will need to set up the configuration file. We have seen the configuration file this morning from Stefan's presentation. We have a global section and a stanza section. By the way, stanza in Italian means room, but the stanza name in English is something related with poetry rather with room. So it's quite interesting choice of names. So inside the global section, we define the repo type, in this case it's GCS, repo path, the path where to create our repo inside the GCS, the bucket name, which is something you have to assign when creating the GCP bucket, the location of the GCPK .json. This file is full of sensible data, so it should be treated like a .pgpass file, accessible only by the Postgres user or the user that is supposed to run Pgbackrest. We also set the repo1 retention full, so we are keeping just one full backup, and the log level console, and also where we are storing the logs. I'm using the same log where the Patroni log are stored for some sort of laziness or convenience. Then we have the stanza. In our stanza, we are specifying the location of the data area, the port to connect to Postgres, and the user to use for connecting to Postgres. I'm not specifying the host name, because in this way, the Postgres user, the Pgbackrest, will use a local Unix socket connection. So the connection will be local, not through the network stack. It will be slightly faster, and they can also take advantage or enhance security by, for example, the peer or the ident method in PGHBA. But if we are not using PGHBA ident or peer, we may need to set up the .pgpass file for having our Pgbackrest process connected to Postgres, because we need to run some sort of stuff, pgstart backup and pgstop backup. This is so inside the directory etc gcp files, we save the gcpjson file. I redacted all the sensible data, but there's for example, an SSH private key, so it's quite sensible, and it has to be treated as something very, very important, not to be accessible by everybody on the machine. So when we are set this thing in place, we are basically ready for configuring Patroni to use Pgbackrest. So what we need to do, we need to use patroni.ctl, specifying the user, the configuration file, and use the command edit config. This will access the data stored into the DCS, the configuration part, and will allow us to modify this value without the editor choice. So in my case, it's just vim. It can be nano, it can be Emacs, it can be anything. In this case, I'm adding the following lines. The PostgreSQL, under the PostgreSQL key, I'm adding under the parameters, archive mode, I'm changing from off to on, and I'm also adding the archive command required by Pgbackrest. So the archive command using Pgbackrest. So in this case, it's Pgbackrest -- stanza test archive -push %p. After saving the command, the patroni.ctl list, it will show an extra column called pending restart. It means we have changed a parameter that requires a restart, an instance restart for being applied, archive mode. And so the Patroni is showing that it needs to be restarted every instance on the cluster before being applied. So we just need to run the patroni.ctl restart followed by the cluster name test. And this is the point. We are not using systemctl for restarting Patroni. We are restarting Patroni via patroni.ctl, because if we do using systemctl, Patroni will consider this operation as a failure of the primary node, and it will fail over on the standby. So we will cause a switchover failover, call it the way you want. If we run the restart through Patroni, Patroni will shut down and restart the primary and secondaries without any risk of having the failover, because it will be managed by itself. And then we are ready for creating the stanza in Pgbackrest. So as we've seen this morning, Pgbackrest stanza create -- stanza equal test stanza create, and then we create the stanza and we can run the backup. And when we are done this, we are good to go, because Pgbackrest, it will store our backup into the GCP bucket, but also our WAL files will be archived safely into the GCP bucket. And now it comes the MCP. End of line. An asteroid, something, it just wiped out our data center, but we are lucky because the GCP bucket is stored in a different availability zone. And so we are left with nothing than the GCP bucket. How do we recover from the GCP bucket? Well, let's reinstall the machines. Let's set up the 3 machines we are seeing before, empty. Again, let's install and configure etcd, install and configure Pgbackrest, again, PostgreSQL and Patroni, set up the firewall like we are seeing before. Configure, at this point, we need a different bootstrap strategy. Because if we start Patroni as we've seen before, Patroni will create a completely new instance. But we don't want that. We want to restore from the GCP bucket. So we need to configure Patroni to bootstrap and clone start a new instance by using the backup stored in Pgbackrest. So we can do this way. Then we start Patroni and profit. First of all, check that Pgbackrest can access the repository. So always Pgbackrest info, it will show you no stanza in the repository or errors or this nice message that says all the data is still there and your employment is safe. So for instructing Patroni for bootstrapping with Pgbackrest, we need a shell script. I grabbed this thing, if I correctly remember, on GitHub. There is an example on this thing. Basically, it just manipulates the options passed by the Patroni process and then build up 2 variables, the data directory and the scope, which is also the cluster name. And that's the reason why I named the stanza after the cluster, the Patroni cluster name. So I can use automatically this value into my bootstrap script. And this bootstrap script, it does a very simple thing. It calls Pgbackrest, it specifies the stanza with the variable scope, asks the restore, and also specifies the parameter link all. The link all is very important because if we have the WAL directory in a different file system and we are using symbolic links, the link only will create the WAL directory into the different file system and will create the symbolic link. Same if we are using table spaces. If we don't use link all, everything will be restored inside the data area. So take care. You need to adapt to the installation of your instance when doing this sort of stuff. In the bootstrap section, we change the method from inidb to Pgbackrest. And also, we specify a new key named Pgbackrest with all the commands we need to run for restoring our database, our cluster. The command for restoring, for bootstrapping, is the file I created in the previous slide. Keep existing recovery.conf, false. I think in Postgres 13 there's no more recovery.conf. This is probably for just for compatibility stuff. Recovery.conf specifies what to add to the recovery.conf part. Again, in Postgres 13 is part of the PostgreSQL.conf. In this case, we are specifying recovery target timeline to latest and the restore command. So Pgbackrest, stanza, archive get, %f, %p. On the other side, the PostgreSQL operational part, we also need to specify extra parameters for making Pgbackrest work. In our previous example, we have written the data into the DCS, but we did not change the configuration file. So we are doing this in this moment. So we are setting archive mode to on, archive command to the Pgbackrest command, but also we are specifying the create replica methods. So how do we want to create a replica when we have already a leader? In this case, we are specifying, again, Pgbackrest, and Pgbackrest contains a similar values we are seeing in Bootstrap. So the command, usr bin Pgbackrest stanza test restore delta link all, parameter we are seeing this morning, delta for delta restore link all for the symbolic link management, the keep data equal true, and no parameters equal true. That's the reason why, because Pgbackrest is not accepting any extra parameter coming from Patroni itself. We are specifying the entire command line into the command. And also we are setting the recovery.conf in this section. And one part I didn't find a way for automating the creation of the directory, so I had to do by myself. So make dir the missing data area, otherwise Pgbackrest will fail. Set the permission on the data area and set the ownership on the data area. This is important. The data area must be in place. It can be full, it can be partially full, it can be empty, but the directory has to be present. Otherwise, Pgbackrest will fail. And that's it. Start Patroni. When starting Patroni this time, we will see the state during the bootstrap running custom bootstrap script is running. The bootstrap script we have specified in the bootstrap section, and this one is just running Pgbackrest restore. So it will take some time, more time than running a normal initdb. But obviously, we are restoring our precious data. When everything is in place, we will get the cluster test and also the database uniquely identifier. It will be the same as seen before. Otherwise, if we are running initdb, this value will change. So we have the Patroni one up and running with the timeline shifted to 2 because we had a failover. So because the Patroni 01 first starts in recovery and then it fails over. So we have a timeline switch. Then we start Patroni on the second node. And this Patroni, it will create the replica as before, not using PG-based backup, but this time is running Pgbackrest. So it will take more or less time, depending on different option. Usually it's slightly slower, in particular because we are pulling from a GCP bucket. And at the end of the process, we will get a leader and the replica up and running. And we have saved the day. I love Patroni and Pgbackrest working together because they save the day. They are, maybe I should have called this presentation like the dynamic duo, but I already use it for Patroni, Pgbackrest, and Ansible. So probably I will think a different name in the future if I add the Ansible stuff to this thing. But anyway, we are at the end of the presentation. I fight for the user. Just a little considerations and some suggestions for implementing this thing properly. This is just an example. So please do not use in production as it is. Work on it, improve it. So step 1, point 1, Patroni and Pgbackrest are amazing. They are absolutely trustworthy and amazing piece of super software that can help us to protect our data. Working with Patroni requires the DBA to change the point of view. Is necessary because the point of view is completely different. Patroni does everything. Patroni, it doesn't implement the DR, but Pgbackrest does it. This example is massively biased, missing a lot of pieces. I'm not using HTTPS, there's no connection routing, etcd is just one node. So if you want to use it as a starting point. Seeing all the configuration we have to do when managing this stuff, using tools like Puppet or Ansible, personally I love Ansible, is a very, 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 very good idea. And final remark, always RTFM. Never start something without knowing what's inside the manual. Because even if you read the manual, there's something that you will miss. Even worse if you don't read. And that's all, folks. There are any questions?
So thank you, Federico. That was a very technically loaded talk, which we always appreciate. So let's
I try to make it entertaining.
Oh yeah, yeah. It's what can mostly entertain a DBA than Patroni and Pgbackrest.
Oh, doing performance tuning on bad queries. That's very, very
yeah.
exciting.
Sure. So we have a bit of time for a couple of questions before we move to the Q&A session and to the next talk. So can you actually explain maybe a bit more philosophical thing? You mentioned that usually we do not like restore from the backup. So basically, Pgbackrest in this case, it's some sort of last worst case scenario. So most likely we will fail over to the replica. From your experience in a such setup with Patroni and Pgbackrest, how often you actually need to restore from the backup? How often could this worst case scenario happen?
From my experience, restoring from the backup has been very, very, very rare. Pgbackrest is very useful if you need to restore large installations, because PG-based backup is a very good tool, but it has one weak point: is single-threaded. So you are using just one connection for streaming the blocks, not connected. So if you have an installation which is 10 of gigabytes, it's fine to use. If you have 12 or 13 or 50 terabytes of data, is something that it will take a long, long time to complete. So Pgbackrest in these terms has shown to me that is an amazing tool for using for cloning the database and creating new replicas or doing any sort of stuff. Just as a matter of example, I restored a 10 terabyte database in 30 hours with Pgbackrest by using parallel processing. I had a multi-core installation, and the restore itself, it wasn't bad. The bottleneck that took more time, it was the restore, the recovery process, because at that time Pgbackrest didn't have the archive push and pull asynchronous, so it has to call every single WAL file with a Perl command. It was also in Perl at that time, so it made a massive improvement in these steps.
Yeah, thank you. We have another question regarding Pgbackrest as well, and it is how Pgbackrest reacts on timeline changing during WAL archiving.
Well, it manages very well. The timelines are obviously the WAL name is designed to avoid to overwrite the WAL with the same name but different timeline, because the timeline is part of the WAL name. And Pgbackrest follows the same philosophy. Plus, it adds the checksum at the end of the archived file, so there's no risk of overwriting an existing timeline when there is the switch. Pgbackrest will show the timeline progression from the start at the end of the archived WALs, and this is up to the person, to the DBA, to choose which timeline to follow when restoring. And this is done as into the Pgbackrest configuration file, recovery option. You need to specify the default timeline. Normally, latest is fine, but if you want to follow a different timeline, you can specify at this in this part. And this will be set inside the recovery.conf for the Postgres still supporting recovery.conf, or into the PostgreSQL.conf.auto when for the newer versions.
Great, thank you. And we almost run out of time. So thank you, Federico, for coming. That was a very nice talk.
For having me.
Thank you.
It's been a pleasure.
Yeah, thank you. And after short pause, we will get to our next talk.